All right, welcome back to the stream. We've got our stream avatars working. And if you want to get a stream avatar, come join the Twitch and become a chatter, become a follower, and you can earn your points and get on screen here as a little Pokemon. So, you know what? I think you lost 5 gold because the minimum bet for slots is 5 gold. So I think you said 1, but the minimum bet is 5. So it should have told you minimum bet is 5. I think it just took a minimum of 5. So there's that. I know that's in the settings, and I was confused with that too, but I'm pretty sure that's what it is. So okay, so today we're going to be adding our different geckos onto screen here. We're going to add our left, right, and down geckos, and then we're going to hopefully get our entity system to spawn. How dare you? How dare you fart on stream? Okay, let's open up our A-Sprite, and then let's open up our gecko, which we've got here in our graphics. We've got a gecko atlas. Oh, really? Oh, that's cool. Yeah, I'll have to check out the app sometime and make sure, or to see what it's got, because that's cool. So here's our gecko. We've got 5 frames for it. We're going to be making a bigger... We want a 4 times as tall canvas. Here we go. And we can do a height of not 16, but a 64. Cool. So... just have to make sure we get these spaced proper. I think that's right. Okay. So this should be easy enough. We just have to rotate these guys. So like when we first made the game, we would manually rotate and offset so we could use the same sprites because they are the same pixels, but there's a downside to that in the sense that you have to keep track of all the offsets and the rotations and all that stuff. So I think what we want to do instead is we're just gonna rotate it all in one atlas, and then we don't have to worry about all the different directions. We just apply it to our entity system, and then it automatically, we just give what frames we want in our entity defs, and then we're good to go. So what I'm doing here is just rotating. Oh, see, we messed up here. We cut off. We have to be careful not to cut off any pixels of our guy here. And then we have to rotate like exactly. So we can say rotate, let's just say 90. So it's perfectly 90, and then we make sure we don't cut off anything from his nose, and make sure the alignment is right on his other pixels. Now we need a 180. I'm excited about the guys. Like I spent a lot of time trying to figure out how to get dynamically inserted usernames into look at him going, man. Trying to insert into HTML with our chatbot. And that, I didn't get very far, to be honest. Like I worked maybe like 8-10 hours on it, maybe more. And I could not figure out how to I couldn't get the usernames to disappear. So like I was able to get usernames rendering on screen, but they wouldn't disappear after being inactive. So, and then in my course of looking things up like this, and I've seen other streams with these stream avatars, I just didn't do it before because it didn't work on Linux. But now that we're on PC, I was like, well, you know what? Now that's now that's a possibility, so why don't we give it a shot and see how it goes. Looks like we've got all of the orientations for the first frame of our gecko, so we just need to get the rest of them, and then we need to save our gecko atlas as a bigger atlas. And what's cool is like we programmed it so that our get quads, our generate quads function takes in the width and height of the atlas. So once we assign it a bigger atlas, the quads will automatically be sliced, and then all we have to do is in our entity defs, we just give the proper frames for these other animations, and it should just work. So I'm hoping it'll be that easy. We'll see. Okay, let's get our other gecko here. So we want a 90-degree. Now I'm being careful to line these up exactly. Like we want them to be, if we mess up where they're supposed to be lined up, then the animations will be wrong on the certain ones. So I'm making sure that this is scooted 1 pixel to the left and our nose is still flush with the top. So that's right. We need a 180. Okay, so we need... Oh, it's hard to see and make sure these are spot on, so... Crap. And you know what? His back foot is messed up here. His back foot is jacked here. Oh, we copied his foot off there. Okay, let's not do that. 180. Yeah, I was watching T Sundown stream, who's making a dinosaur game, which looks really cool. He's got all his subs as stream avatars on screen, which is cool. And it just looked like fun. I didn't realize that the slots and the roulette were part of stream avatars. I thought there was other stuff he did, but it looks like it is part of the stream avatars. Okay, so we need to make sure it's not here, it's 1 pixel over, and then we get our third one, or yeah, 270. Okay, and we give it 1 pixel on the right there. Yep. Okay, that should be right. Let's do our next one. I copied his foot wrong there, didn't I? No, it is an L. It is an L like that. Okay. I don't think I like that. I think I want to change it, but that animation looked good, didn't it? We worked... Yeah. Ugh. Let me look at the gecko and see if it bugs me. If I really look for it, it doesn't bug me. It looks fine. It looks fine. So it is a little more work. Like, if we want to make a 1 pixel change to this character now, we have to change all of the directions. So it's kind of a lot more work in that sense, but in terms of getting it working in the game, it's a lot less work. So we're rendering at a Game Boy sized resolution, so I'm not too worried about the graphical demand of it doing it like this. And we keep accidentally overriding some pixels on accident. Feels so good to be back to game dev instead of working on Windows crap, dude. Okay, we're already almost done with all these geckos. Let's see if we spot any mistakes. I don't see any. Okay, let's give it a shot. So we'll export this as Gecko Atlas, and it'll overwrite our first Gecko Atlas. So our first Gecko Atlas was defined as a drawable, which is the same name, but then it was running the generate quads function on it because it was a animation. So I'll show you what that looks like. If we go save as PNG gecko atlas.png, we'll overwrite our old one, and we'll switch back. Now we should be. We gotta harpoon a couple more things. We gotta harpoon like our constants and our map declarations and our entity defs. So we've got a player defined here. If we go down to our gecko, we've got our frames for right now we've got okay. So we've only got one idle animation, and we've got a walk directions, but they're all being populated with the same frames. So we just need to populate our frames tables with the appropriate values here. So we can take a look at, and now we could use our Python. Should we use our Python script to put our numbers on the page here? Let's go into our, what is it, graphics? CD graphics. And it is our draw nums py. So let's try to run it. Yeah, let's try to run We do have to edit it to give it the proper atlas. So we would have to go out here and say, oh, and we don't have our tmux session. Let's get our tmux. Here we go. We'll call it geckos 4 ways. Cool. So we got our tmux back. Let's take a look in our graphics Python script. Now we're opening an image called master sheet. Now what we really want to do is open a image called geckoatlas.png, like we just saved. So we'll say geckoatlas.png. Now it should, and this sucks too. We have to give it the right. It is a 16. But it is not this. I'm going to keep these here because we do want to use this function, this Python script for our map generation, but we need to define it in terms of the Gecko Atlas here real quick. We have to tell the Python imaging library the exact specifications of where we're trying to draw these things. So we have 4 directions, so it's 4 tiles high. And we have 5 frames, so it's 5 tiles wide. Cool. And then we're going to be opening our Gecko Atlas, and then we should be printing, we should be saving a tiled numbers PNG here. So I guess the question now is, do we have Python imaging library installed on our Windows or not? Let's see, Python 3, and we're trying to run the script drawnums.py. Python was not found. We don't even have Python here. We could do it. We could do it in the Linux environment. Let's see if we detach here. Let's see, and we should have Python 3. We do have Python 3 here, but I don't think we have the Python imaging library. But let's see. Let's see if we go into our graphics. Now we should have, yeah, drawnums.py. So it's Python 3. That's how we run this Python script called drawnums.py. No module named PIL. So we do have to install that. I think we can do pip install-m pillow, which is the name for the Python imaging library. Maybe it's not -m. Maybe I'm making that up. Pip install pillow. Oh, it's working. It's working. Okay, now let's run our script. Python 3 drawnums.py. It returns nothing, which is a good sign because it didn't fail. So now we should have that picture. We should have the picture in our folder here, in our graphics. It's called tiles numbered. That was the not right one to click. And we should have it. Let's see. Yes, look at it. In its glory. We've got our Gecko Atlas with the numbers that we need. So we can leave this up as a reference because this is what we're going to use for our drawnums, or our entity defs actually. So we can attach to our tmux. We can go back to our entity defs, which we got harpooned here. Maybe not. Maybe we didn't harpoon it. Entity defs here. Okay, entity defs. Got a harpoon now. So our walk, like this is in our player. So let's get to our gecko. Here's our animations for our gecko. Now we've got walk up. Now look at the frame numbers for walk up. It's 1, 2, 3, 4, 5. But that correlates to our quads here. So for our walk down, and this is where this image really helps us kind of just look at this. So we know our walk down is going to be frame 11, frame 12, frame 13, or yeah, I should say quad, because it's the same atlas, just a different piece of it. And then our walk left, it's going to be 6, 7, 8, 9, 10. Okay. Walk right. I feel like it's easy just to do it like this. 16, 17, 18, 19, and 20. So that should be all of the quads for our gecko. Now, I think we're setting our animation based on our direction. Oh, there's the star. So, AKA Bob, you could jump to get this star. Yeah, you could jump to try to get that star. It's probably hard to time it, but let's see. Oh, I just missed it. Yeah, too early. Yeah, I think it's like 10 or 15 gold if you catch it. Okay. Oh, dude, yeah. Shoot. Well, now I want to get the star. Okay. So we'll check to see if we've got so Jeannie, there's it worked on Jeannie, so maybe she did oh, there she goes. She's Doduo. Get the star, Jeannie. Grab it. I know, yeah. That's the hard part, because it's like you don't know when the command comes in and to the stream, so it's not as easy as it looks. Look at the Doduo chasing it. That's so cute. Get it. Oh no. You know what? Here, I'll give you guys another chance here. I'll drop another one for you guys. Oh, that's so much fun. Almost, Jeannie. That was close. Oh my gosh, you guys are right there. Oh, this is too fun. Okay. So I'm curious where we're setting our direction. Did you guys grab it? Oh, Akabob got it. Good job. Yeah, it's the lag because everyone's live stream gets to their phone a little different, you know? So, and then by the time your command gets sent and then my game receives it and then it renders it, there is definitely a lag there. Okay, so we're gonna see. Let me know if you guys want another star. I can always just dump one on there, so. Yeah, my voice is lagging. Okay, I want to go see where we're instantiating our gecko and seeing what we're doing to it to either make it walk a certain direction. Yo, 26 gold. Dude, you almost have enough to buy Captain America. Dude, yeah, you're like 4 gold away from earning a cap avatar there. And I think Captain America actually has some different skins too you can buy. Yeah, moving so you can slots it up. Yeah, dude. Yeah, dude, slots it up. Come on, let's win big time. No whammies, no whammies, no whammies, no whammies. Yeah, well, I think I was just looking at the stats and it was like, it's like I don't remember the stats. I want to say it's like about every other slots is a winner, but I don't remember. Okay, so we're inserting geckos here. Now, we're automatically setting their direction to be up, and then we're changing their state to be an entity walk. So, I'm curious if our entity walk state has anything that says, hey, change our animation depending on our direction. I'm kind of curious if we set it up like that. Let's go to our entity walk states. Now we'll say okay, see, and this is here, this is it. We init our animation to be walking. So right now this is hard-coded as a walking up gecko, so that's no bueno. Here's another star for you guys. Yeah, when we... Okay, so what's happening here is when we change our... Let's see, if we go into our scene class, we're changing our state to entity walk. An entity walk is an entity walk state here. So what we need to do is we need to change it to the certain animation here, but we need to change... That was close. Ekans, that was real close. I think in our init function... Oh, dude! Oh, that should have been you. That was like 1 pixel away, man. Dude, I know. That was like 1 pixel off. I could have sworn that was it. Maybe because the star was like on its upwards trajectory by the time you did it. Like you get more luck in that RNG when it's down like this, like this. Oh. Yeah. Shit, man. Well, yeah, you'll get capped soon here. You'll get some more points. I don't think you get any points for farting, but you can try it. I think in our entity state init, we need to change our animation to be the direction that we're facing, because when we go ahead and insert the direction into our entity spawning here, we do have access. Right now it's just up, but if we were, for example, to put up as part of the change animation that we're inheriting from, we should be able to get our dynamic directions in there. So let's see if we can go into our entity walk state, which we need to harpoon. So we'll go harpoon that now. Yes, we need to set... See, look, we change... Okay, so let's test this. Let's say... we'll say that we set our animation. We need to set our animation to be walk hyphen... Yo, back at the slots. We go walk hyphen, and then we convert to a string, and we pass in our self.entity's direction. Now, our self.entity's direction... Yo, nice. Good job. Self.entity direction here, I'm thinking should be... So I think you have to say, you do command by space avatars with an S, and then Captain America. I want to say it's all one word for that, to buy the avatar. We also got Iron Man, we also got Doctor Doom, we also got Deadpool, Wolverine. Those are all worth 30. I think you've got 30 at this point. Or you can buy a third evolution Pokemon. And Genie, I gave Akabob some coins already, so I can give you some currency too. So all I have to do is say currency add, and then I can say Genie Gray. Then I can say 20 gold here. Booyah. So Marvel characters are 30 in the store. So they're the same as third evolution Pokemon. So you're getting close to getting a Marvel character. And then I don't think there's a way for me to check. I think, aka Bob, in your thing to see which avatars are available, and then you can see what the title of Captain America is if that's the one you want to get. There's a Spider-Man too. A Spider-Man 1, but Spider-Man also. Okay, so we've got our self.entity direction. Now we're already checking these in our update function to go give us the proper direction update, like the positional update over time. So we should have no problem setting our animation to be the walk animation of whatever our entity direction is, because in our entity defs, we've got walk hyphen and then the direction, which our self-entity direction should have at the moment. So I think that's right. Let's see if that crashes. So we've got entity walk state. Let's see. If this doesn't crash, I'll chuck you guys a star. Okay, I reverted back to my old ways. This is not right. We need to go here, and then we need to run our love program. No code to run. It's because we are in the wrong directory. We'll run there. Okay. Expected. We missed a parentheses. It should be in our entity walk state, and it should be right here. And we need to concatenate this with the concatenation operator, which is a ... in Lua. And then we should be able to run. Okay. Okay, so the fact that these are still walking up tells me that their direction, that their animation is inheriting the direction. Yo, that was sick, Ekins. That was sick. How'd you do that? Did you do sling? Was that sling? Uh-oh. Wrong. Gotta minimize that. Okay. Nope. Wrong thing. Okay. There's also, like, I can open up my God panel and I can sling you guys around too. And there's even bombs. I think you can buy a bomb for like 10 gold, I think, too, and you can go bomb somebody. But don't take me out of context on that. The stars are really fun. I'll probably increase the rate that the stars are falling because those are fun. Okay, I think this is working because in our init we're changing our animation not to one animation but our direction animation. So I guess the question is now, if we go to when we spawn our geckos, which is in our scene class, and instead of giving a direction up, we give it a random direction. Now, we need to make sure they're all in the same spot, because right now they're off screen at the bottom and they walk up into screen. So we need to make them in the middle so that we can give them every direction so that they can kind of just go spread out. So we'll work on that. And then we'll go, I think, yeah, instead of giving us a random position here, let's go ahead and change this. Now we also need a way to access a random direction as a string. So what we can do is just give ourselves a table of all the directions, and then we do a math.random value. How do we do this? We'd have to say math.random. If we put in a hashtag and then our table, it'll give us it'll give us a number, and then we need to go ahead and index. That was close, Akabab. Okay, we'll figure that out. Let's not worry about that just yet. Let's just try to see if the other animations work. So we'll give ourselves a math.random, and actually let's just give ourselves, we'll say that our x is actually our virtual width divided by 2, so the center of our screen, and then we'll go delete cache, and we'll say our y is going to be our virtual height divided by 2. And then we need to make sure we give ourselves commas here, and then now they should still walk up, but they'll be right here in the center of the screen. So let's see that. Yeah. Now, and the thing is, there was like 5 geckos there, but they all have the same starting point. So all 5 geckos were in the same exact spot. To prove that, we can do this, which is math.random, and we give it 2 values to go in between, so that they're not all in the same spot, and we can say minus 20 pixel difference, but then the other argument is a positive 20, so a total 40 pixels spread on the difference, possibly, and we'll see if we can do that. Change this to a plus. Okay. And then let's see if that gives us 5 geckos now. Man, I'm so used to leader M running our game. It's gonna take a while. That's my least favorite thing about this setup here, is that we can't leader M anymore. So I'm not very happy about that. We forgot our comma here. Yeah, I don't like that, but see, yeah, okay, so there was all 5 geckos just all in the same spot there. So the test here is now, if we change our direction just to left, do we have the left animation? That's the question. I forget leader M every time. Okay. Yes, dude, we got our left animations. Now let's test our down. So we'll go change down, and we'll try that. We've got our down animations, great. Now, let's test our right. Nice, all our animations are working. So now we just need to, in our scene class, when we instantiate our geckos, let's give us a random direction and a slightly random spawn point, and then we should be able to see if the animation or the entity system can handle the different directions here. And then if that's good, then our little outline is like the cool thing is, we didn't even change the atlas. We changed the size, we changed the size of the atlas. It's still the same drawable as far as Lua is concerned, but we were able to add 4 times the amount of sprites and somewhat very easily change the animation style. So it's a lot easier than rotating, offsetting, and then keeping track of which frame we're at, for which direction we're at which time we're at. It's a lot easier than that. So that's going to be good for our system, and then maybe we can start our collision detection for our overworld, which would be fun. Well, it's going to be tough. And it's something we need to do. And then once we get our overworld collision detection, then we can build out a little kind of 4 pixel range for our game. And then that's when we can start to add a bad guy entity. And then we can work on our magic casting, or we can work on our magic casting first, then add a bad guy, and then build in the interactivity between casting magic and a bad guy. And then we'll talk more about those details about what the bad guys are what type of magic works on what bad guys and what that is going to look like in the game, but we'll get there when we get to it. I'm excited for it. Yeah, I'm really liking the stream avatars. It's really fun. Okay. And I guess, I guess a better way to do this is to like leave this open over here for me, and I'll leave it in the background, and I can just dump a star whenever I want. I don't have to open it on stream here. So that's probably the better way to do it. The jumps, I love it. So fun. Oh yeah, that syrup is good. Okay, so here's the tricky part. We want to populate this value here, this dot direction, not with one string, but with a possible of 4 different strings. Maybe up, maybe left, maybe down, maybe right. So how we do that is we need a random number, and then we need to index our table of these directions filled with strings, and then set our direction to be the index of the table dereferenced index of the, what would I even call it? So instead of, yeah, I think that's the way to do it. So like what we can do here is in our init will give us a table of potential directions. There might be a cooldown for jump. I'm not exactly sure. Yeah, there. Oh, and you know what, Jeannie? It's oftentimes a Twitch thing. So they don't want people spamming the same comment over and over. So if you do exclamation jump space anything else, like you can say jump 20, even though that 20 doesn't mean anything, it'll tell chat, hey, this isn't spam because it's a different message than was just sent, and then it'll let you send it. So that might be it. Because it's like an anti-spam thing for Twitch. So we're going to give ourselves a possible directions table. And then we're going to say, nice catch. We're going to say that this gets some strings. And we're going to say there's a left string, there's a right string. Yo, how much gold are you sitting on now, aka Bob? This is like the SpongeBob slot machine all over again. We're gonna have to add some like legendary items for you to save up for. Okay, cool. So we've got a table of 4 different strings. Now, what we need is, for each entity, we need a local random index so that we can pull one of these random directions out. So what we can do is, once we're in our for loop here, we can give ourselves a local random index. And that is going to be a math.random of 4. So that is just going to return either 1, 2, 3, or 4. Now, what that allows us to do is to spawn, instead of giving a direction like right here, what we do is say, oh, dude, yeah, buddy. Oh, that's awesome. Dude, go attack me, go attack me. Oh, that's awesome, dude. That looks so clean. Oh, that's great. Oh, that's really cool. Oh no. Oh no. Oh no. Dude, the punch that went clean over my head and then kicked me off screen was classic. We gotta clip that. Can you clip that, aka Bob? Oh, that was good. Dude, we're about to hit affiliate, man. People are gonna come here and they're gonna stay. They're gonna be like, let me get a Captain America. And then yeah, so like they're, man, he's so tall next to that Doduo, man. He's just gonna, oh, that looks so cool. That looks really cool. Yo, Genie, yeah, you can buy Rogue. So you gotta do exclamation point buy space avatars with an S, and then I think it's just Rogue. Yeah, it's buy and then space avatars, and then I think you'll be able to do it. It doesn't. Nice. And then it. Yup, there you go. Oh, that's awesome. That's awesome. Yo, okay, so then we're going on a Marvel kick here. So let me do So Jeannie, you can do exclamation dance, and she should dance. Yo, look at us, look at us. Yes. Oh, dude, did you see the jumps? Oh, that was sick. Oh, you don't like the choreographed dance? Oh, that was worth it. Oh, no. Oh, no. That was too cool. I want to see what Iron Man's sleep looks like. Oh, I don't know if he's got a sleep. Does he have a sit? Oh, he's got a sit, but not that great. That's cool. That's cool. Oh, this is awesome. That's really cool. This was... So this game was... Yes! This game was $15 on Steam, so I think money well spent. Yeah, easy. Like whoever came up with this was just brilliant. Like, you know, such a smart idea. Okay. So what's great here is we can assign our direction based on, right? Yeah, $15. No biggie on that. So that's cool. We assign our direction here based on our random index of our possible directions table. So what that means is we can go into our possible directions table, which is like this, and we do brackets at the index of our local variable random index. So that'll be either 1, 2, 3, or 4. And putting in the index there will give us the string of the possible direction. And that is what we're assigning into our dot direction for our random gecko entities. So we should be able... Yeah, I don't know what the color schemes are. I just know there's a couple different skins for a couple of them. I don't exactly remember how to change the skins, so you might have to figure that out. I think there's if you do a command help me, it'll give you a link for stream avatars commands and stuff. It would be just help, but my bot has a help. Oh, well, maybe it shows you the pictures and everything on there, because I know it's got those on mine. So I can just make a different color scheme or something and add it, but I haven't messed with it too much. I just got it today. Let's see if we get our different directions here. Yes. Yes, did you see them spread out like that? So we should be able to, and none went down, but I think that's just a random, actually, none went down again. Is that just a coincidence? Let's give us more than 5 geckos. Because we should have the possibility to go downwards too. So let's try it. I keep doing that, but let's run our game. Okay, they are all working. So now we've got all of our geckos going in different directions here. This is great. This is all I really wanted to get done today, just to kind of prove it. We do have to add our get SSH key to our new PC machine, but I guess we can start kind of talking through what our collision detection for our global map might look like. So, yeah, maybe we get working on that. Let's pull up. I kind of like this in the background here while well, I guess it depends because I'm actually going to go load up GIMP. Oh, good night, buddy. Have a good night, dude. Don't make me sing SpongeBob for ya. Oh! Okay. We don't have... Let's do this 3,000 by 2,000. That was not right. We need to make just like a default GIMP profile for me to take notes on. Oh gosh, I'm just so bad at GIMP. We want our canvas size. Where's our canvas size? Image, canvas size. 3,000, not 300. Okay, resize. All right then. Okay, yep. Exactly what we wanted, y'all. I had this set up on Linux, but you all know what happened. Oh God. Why does it do this to me? Okay. We're just gonna get a nice dark color. Not what I wanted. Oh my God. Yeah, I should have had this set up already. We need the paint bucket. Cool. Okay. Now we need to save this as a documents. GIMP right. Now we can go ahead and get all these away. Oh, you know what? There's a way to default it. Preferences. It's like a default layout. We can do a image window management default window. Oh God. Oh Lordy. Okay. Where is it? I'm trying to remove the everything from here so I can just write on a blank screen here. Here, default. Okay, so no menu bar, no rulers, no scroll bar, no status bar. So if we say that, then if we open up new GIMP right, and it's still there. Okay, well, maybe we just figure this off. Show guides? Nope. Dude, why? Is it Shift Tab or something? Tab? Tab. Oh, and there's no full screen mode. Is there really no full screen mode? Oh my gosh. Is there really no full screen mode here? F11 is full screen. Okay, so maybe it's... I can't even figure out how to resize this thing. There we go. Okay. So if we tab, actually if we F11, that is full screen mode. Shoot, I hate that it shows the Windows bar up there. Okay, I guess we just gotta live with it. I don't like that it shows that. On our brush tool, we'll give ourselves a brush, and it'll be smaller. Okay, cool. So now our GIMP write, we can use our tablet here, and we can write some stuff. So I'm trying to figure out how we're gonna pull off our global map collision detection. Now it's gonna be, right now, we can walk over any tile. So we need a way, whenever we switch scenes, we need to be given the data for which tiles we can't just walk right over. So there's a couple of ways to do that. What we can do is we could have collidable entities, right? So a collidable entity would have an X and a Y position, as well as a width and a height position. And it could be defaulted to a one tile, so that, let's say, for example, there's a tree stump. There's a tree stump, it's 16 by 16, and you can't walk over it. So it would be a collidable object. So there's two parts to this. It's like we gotta declare what objects are collidable within our scene, and then we need to do the collision detection to determine what type of collision was happening, so that we can reset our player's location. So like in the game, since it runs 60 times a second, what really happens is we check every frame, hey, are these two squares colliding? And if they're colliding, we need to see how they're colliding so that we can move them appropriately, because the game doesn't know, oh, he came from this way, so we should unmove him the other direction, unless we tell him, hey, that was a right collision. So our character right collided, therefore align our right side to be shifted so it's not colliding anymore with the object. So it doesn't know which way it collides unless we tell it and write these collision functions determining how it collided, so we can reset it. So what actually happens during the game is 60 times a second, it'll either, if you're holding a direction, it'll update your position, and then it'll check, hey, is that position collided with a collidable object? If it is, what type of collision is it? So we know, oh, we need to move it back left because we moved right, or whatever that may look like. And then we have to, holding the direction would move it. It would be colliding. It would say, oh, we're colliding. Let's unmove us so that we're not colliding. But that means under the hood, the game is literally calculating, hey, we're in the middle of this object. Let's unmove us. And then the next frame, if the direction is still held, it'll say, hey, now we're in the middle of the frame again. Let's just move us because it's colliding. And it'll be resetting it over and over and over, 60 times a second. Because unless we do a different way of collision, which is not as easy as what's called AABB collision, which is what we're going to be doing. So AABB collision is going to be squares. It's only squares. So AABB collision is just detecting whether or not two squares are intersecting. And how we do that is we say, hey, is the left side of us smaller than the right side of this square, and the left side of us is greater than the left side of this square, as well as the bottom and top, to determine a collision. So we'll have to write collision detections for bottom collisions, top collisions, left and right collisions, so that we know how to move our character appropriately. Because when you think about it, if our player is inside, like let's say our two players are colliding. So like here's our sprite, here's a tree stump sprite. If we're colliding, we can infer from looking at these squares, like, hey, that was either a bottom collision for our player or a right collision because of the location. There's only 60 frames in a second and the walk speed isn't that fast, so we can kind of tell where that collision is. But if this is a perfect square here, we can't tell, hey, was this a right collision or a bottom collision for our player? We really don't have a way to determine that. If it's a perfect square like that, it would come down to the order of operations of when we declare, when we run those functions. So that's going to be tough. So I think the move is we need to make a new class called collidable object. And this is tough because our entities, well, yeah, it's hard to think about because our entities are ultimately going to be collidable objects, as well as anything on the map can be a collidable object. So it's kind of, I don't really know how to go about this. Because ideally we can use our left, right, bottom, and top collides functions for anything that has collision boxes, which could be an entity or it could be a map or a map tile. But I don't know. Yeah, I'm a little stumped. I might have to think about this. And we can make some notes in our NeoVim here and kind of try to break it down. It is nice that we've got our geckos in different directions here. What we can do is give our X a math random position as well. And we could do something similar, say -20. And then the other direction is going to be the width divided by 2, but a +20. And then we can see, yeah, that's going to be fun. Okay, so yeah, we're going to have to really think hard about the best way to implement our collision detection for map objects, because ultimately we'd want our collision functions to scale with our entities as well, because they will also have an X, Y, a width, and a height, so we shouldn't have to do those functions twice. So maybe that means, hey, look at the star. That wasn't me, that was the game. Yeah, and you know what? Maybe we just give yeah, maybe we give our map objects that are collidables, maybe we make those entities, because yeah, I think if we give like say our tree stump in the bottom left there is 4 sprites worth of trees, right? So if we know that when we switch the scene that, hey, map 1-1 has a 4 tile size entity that is going to be a tree, we would give it an X and a Y and a width and a height, and then we can run, and we will already be running collision detection for entities, and we can say if you collide with an entity and it is a type enemy, then that means we would take damage, we would get flung back, and then we would, I guess we would also say, hey, if we collide and it's a type map object, then reposition us and we don't take damage. So maybe that's the move, is we give, for example, our tree here, our tree would be an entity, not of type enemy. Oh, that was a nice catch. I think that's the move, because then we can write the function once for our top, left, right, and bottom collision detection. We would just write that function once, and we can use it for our enemies as well as our map objects. So I think that's the way to go about it. So I wonder if we can piece together a little function that tests for AABB collision, and if our player collides with an entity, with an XY, with a height, if it collides, not even bottom, left, right collision, but just any AABB collision, then maybe we can turn it red. Like turn the sprite that it's colliding with red, so that we can just test, hey, we're just checking for collision. We're not trying to limit our movement just yet. We're just deciding whether or not this collision function's working. So maybe that's a good way to start. And then we expand upon it and then do bottom, left, top, right, and then make sure it moves us, prevents us from walking over a tree if it's a collidable object. So let's go ahead and get started on that. We'll see. Cool. So what we can do, this is fun. I love the stream avatars. It's really fun. I am missing my Dragonair though. I think I'm gonna go back. And I might shrink the Marvel characters just a bit so they're not so huge. Like they're like twice as tall as a lot of the Pokemon, which makes sense, but I might shrink them a bit. We might still figuring out the tweaks, but look how far the stream has come, you know, in just a month. You know, we've got a lot of stuff going for us. It's really cool. Okay, we're already at 1:30. I did not expect that, but let's take a look at our entity class and just see if our idea might work, because we might be way off. So let's take a look at our entity class. We don't have it harpooned. Let's go ahead and harpoon it. Here's our entity class. We'll harpoon it so we have easy access to it. Now, we do inherit a direction, which is okay because it needs a direction to be updated. And if we don't set a direction, like I guess what we could do is okay, yeah, there is another thing we can do here. Like what we can do is we can also say def.direction or and then a string. So what that'll mean is this direction gets set to whatever our entity defs says it is, and if we don't define it, then it defaults to a down. So we could do something like that. I don't think it's explicitly necessary because we actually just overwrite it after we make the entity itself. Yeah. We don't need to do that. It's just something we can do if we want to tidy it up a bit or take our explicit definitions of our directions out of after we initialize it. But it doesn't really matter. Let's keep looking at our entity defs. So yeah, this is what I'm saying. How an entity has an X and a Y and a width and a height. Those are all we need to do for AABB collision. So we've got those already in an entity. Now, the other things I'm not so, look at it, look at us. We already got AABB collision baked in. We already got it. And this is true AABB collision. So what AABB collision is a basic rectangle only collision detection. So if the two things we're trying to detect collision are rectangle, then this function will return true if those two rectangles are intersecting in any direction. The orientation is always going to be straight up and down, but this will detect if those are colliding. So yeah, maybe we give ourselves a test entity called tree, scene 1 tree or whatever. We give it an X and a Y and a width and a height. and then we run this entity collides, and we give it the target of our player that's in our scene. And then that'll return a true or false, and then what we can do is we can have, like, we would want to render our tree as being red if it is collided with upon a player. So maybe what we do is I don't know if we do that. Like, does our entity have access to our player? It doesn't. So we would have to, okay, I got it. In our scene render function, we can ask this, hey, does this map object entity collides with target self.player? And if it does, then change its render. Yeah, how do we do that? Because when we render it, we go ahead and set its color to white. So we would want to set I don't know how we would. Well, okay, so instead of changing the color that our entity is rendering, what we could do instead is render our entity and then render over it a red square of our entity's X, Y, width, and height. And then that'll give the illusion of just rendering red only if we're currently colliding with that object. So let's test giving us a map object entity called tree. We'll place it where the tree is, and then we'll try to trigger a red square over the tree. If our player is colliding with it, we won't be moving our player just yet. We're just testing the collision function, and then if that works, we can call it a night, and then tomorrow we'll work on actually adjusting our players. That was a nice catch, Jeannie. That was good. Her little kung fu dance was too good. Yeah, we'll call it a night if we can get our red tree rendering here. So let's go ahead and try it. I'm gonna get rid of the geckos in the back here because I want to see that beautiful Sekiro art. Cool. So we'll go. Let's check out our scene because I think this is where we would want our new entity object. Now, how we get an entity is we could manually instantiate one, which we probably will do. How we do it here is a little different. We give it a curly brace, and then we set all the definitions inside that, and we insert that into a table. But what I think I want to do is let's get our X and Y width and height of our tree. Which let's take a look. Oh my, I miss leader M with a passion, guys. I used to be able to run the game with 2 buttons. Now I gotta do 2 buttons plus typing love dot plus enter. So it's a tragedy. Dude, how'd you jump that high? How did you jump that high? That was insane. Okay, so it looks like this, okay, now you're just showing off. So if this is 1, okay, so our game is 10 wide and 8 high, I believe. So our X and Y should be tile size times 6 times 7, and then this would be times 8. Because times 1, tile size times 1 would be, no. 0 would be here. Okay, tile size, so it would be 6. Okay, so what we're going to do here is just try to get a red square over where that tree is. So in our scene, the last thing we're going to do here is draw a love.graphics rectangle. And we've got to set the color for this, but for right now, we're just going to put rectangle. We're going to put an X, a Y, and a width and a height. Now we need our X, which is going to be a tile size. Now it is at the 6th tile down. So it should be tile size times 6, because times 1 would be the first one. So times 6 should be the 6th one. And actually that is just for the Y. Our X would actually be 0. So we'll say 0, tile size 6, and then a width and a height, which our width is 16 times 2. So we'll go 32 width, 32 height. And then we need to set our color for this rectangle. So we'll go love.graphics.set color, and we'll give it, do we have red, y'all? We got, let's see in our constants if we've got a red. If we search for color, we don't have a red, so let's give us a red here, a red constant, and we'll set it equal to a table of 4 values, all of which are 8-bit colors for our red, green, RGB values, 0, 255, and then a full 255 out of 255 for the alpha. Now, we should be able to set our color, draw a rectangle, so let's see if this is right where our tree is. Let's see. Nope. Oh, we need a fill. Okay, the first argument for love.rectangle is a fill type. So we need either line or fill. We're going to give it fill, then XY width and height. So we should be able to try it now. Let's clear it out. Let's clear it out. I'm not a fan of Windows Terminal Wheel. Okay, it looks like we've got red, and that's because we gave we got black, not red, because we put 255 for everything. So in our constant declaration here, when we go set our red, we need to actually set it to be not 0 everything. We need our red of RGB to be full 255, and then we should have a red square where our tree is. So this is looking right for our how are we coloring our monas? Because that's red. We will be able to pass in red for that now that we've got that constant. But we only want this red if our player's actually colliding with it. If our player's actually over top of it, we want it to be red. If not, just be a tree. So let's go back. We'll go into our scene. Now, we would only do this. Okay, so here's what we do. We need to instantiate an object that is an entity, because that would have an XY width and height and access to the function of our collision detection. So we need to go make us that entity first, and we can just give ourselves we can call it tree lazily like this, and just say that an entity, we say entity, and we give it oh, you know what? We can't declare it like this because we don't have parameters. The only parameters we have are in form of definitions. So we actually have to do it with the table method. But that's totally fine. All we have to do is do a table like that, and then we set inside here the stuff. So we can say X of our entity gets set to be equal to the tile size times 6. Actually, it's 0. No, it's 8. No, it's 9. This is tile size times 6. And that's a magic number. Width. Now, I think we can get away with just calling it these local variables, because that's how we do it for geckos. We do need commas there, though, so and we don't want this in the entity walk state. We want this in the scene. So we'll take that out. We'll go back to our scene. We take a look at our geckos real quick. We have, yeah, you literally just do the tables and then you call it whatever local variables they are. So let's do that right here. And we'll say our tree gets an entity instantiation with an x0, a y of this, a width of 32, and a height of 32. And then we make sure we got commas here. So now typing in tree gives us access to the fields tree.x, tree.y, tree.width, tree.height, and any functions related to a entity class, which has a colon collides with a target function. So our scene has an entity called player that has x, y, width, and height. So that means we can run our collide function with that player. So let's go ahead and try it. Let's see. We can say if tree colon collides with target self.player. If they're colliding, then we want to do a thing and render the red square right where that tree is. Now, otherwise, we want to not render that screen, so we can just leave this out. We only render a red over the tree if we collide with the player. Let's see. If leader M, I'm so sorry. I am so sorry. Okay. Table expected. So, bad argument 1 to pairs in entity 22. Entity 22. Pairs. Okay, entity needs an animation. Okay, that's not so great. We do need to define an animations because we create animations right here with it. So our entity by definition needs an animation, which isn't what we want to do. We can give it an animation of a gecko. It doesn't really matter. Yeah, I think we can do that. Hey, see ya, Genie. Thanks for hanging. I know, I missed it too. I just saw it now, too. So I think Stream Avatars has it set up, or I set it up in Stream Avatars where if they're not an active chatter for 5 minutes, I think, their avatar will go away. So by the time she goes away, she was, 5 minutes gone from her last interaction. So that's super fun though. And if anyone else ends up joining, we can try a battle royale, and all you'd have to do is command battle royale, all one word, or exclamation battle royale, and then it'll send every avatar to go fight against one another, and then it awards the winner, I think, 30 gold. But yeah, we should wait. If there's some more peeps in here, then we can try it. But so far, it's just been us chatting. Okay, so we need to give a dummy animation to this entity because we're running this now. Maybe what we can do is say if there is a self.animations, like if we define it with one, then go ahead, run that function. Otherwise not. Maybe that'll work. So that way we don't have to give it a dummy animation value. No, it's because it needs to assess it. So it's asking, hey, does that animation have an animation? And it doesn't have anything to go with. So we do need to assign it. Let's just give it our gecko animation just for the only reason of getting it to not crash. So we'll give it this. So we'll say, hey, you've got an animation, it's called Gecko. We're not rendering anything with it, but you need it. Let's see if that works. Entity walk state. Okay, well, we need to change it to be idle state because a tree can't walk unless you're in Lord of the Rings. So we'll go, we need to set our state of our entity to be equal to, we also need this. We also need the state machine. Oh, yeah, okay. So this is one con about doing it like this, is because we need to, it's almost like we need a separate entity for map objects. We can decide that later, but let's do entities, and it's not, this would be tree.stateMachine. Tree.stateMachine gets the state machine states, and then we would say that we would change our tree's state machine to be not an entity walk, but an entity idle, which waits for movement, which doesn't happen yet. So I'm thinking that'll work. Let's see. Entity idle state. Entity, field entity, a nil value. So entity idle state. Let's go here, entity idle state. It's looking for an entity, so we need to pass in the entity. Okay, that makes sense. We need to just pass in the entity here. So instead of, well, that's weird because we don't pass in the entity here when we change the state. So it's like this where oh, did you see Jean just explode? Your kill was just it just took a little while. Dude, she just exploded. Oh. Dude, it shattered her to pieces, man. It was wild. Okay. So I think only a... no. We should be able to... Does an entity have a state machine? It does have a dot state machine change. And that takes in a name, which we're doing. Okay. We might have to just make a totally new map objects class. We might. Let's go, let's go, let's go, let's go. Yeah, I have a tough time getting clips working too. I don't know what's exactly going wrong here. We're trying to index a field entity, which is a nil value in our entity idle state. Now, if we take a look at our entity idle state, we actually have to pass in a dot, or we have to pass in an entity in the init. I guess what's weird though is that we don't really do that for geckos. I don't understand why it doesn't work. What we have in our dot entities an actual entity, and then we're saying the entity itself at the ith entity, which is where it's inserted, gets a state machine of this. So, oh, nice. It was wild, huh? Okay, this is it. This is it. This is it. This is the same problem we did multiple times before already. So instead of saying self entities for this, we need to pass in the tree. And then the tree here as well. Okay. Before I say that was it, let's run it and see. Yeah, okay. Well, it's still broken. Now our entity idle state takes in an entity which we are giving it. And it's crashing here in the entity idle state. So when we give it tree, our entity idle state, which we will harpoon now, is initted with an entity. So our dot entity, but what line is it crashing on exactly? Entity walk state 4, like right away. So it's not getting an entity when we pass it, when we go to idle. So we need to make sure that we are giving it the tree entity here. Now, tree is an entity instantiation. We should have that. And then our idle state only takes in one parameter, which is an entity, but we're crashing right away. Change state is ran with the colon. And yeah, we're running change state with the colon, so it should let us do this. I wonder if it's something wrong in the, like, I guess I want to see if our, like, if we don't change to this entity, we should be able to run no problem. Well, we don't. Let's comment out this state machine and see if we're able to run. We still are not. It's because an entity needs... Okay. It's because our actual entity class needs to be given... Actually, I don't know why it's not letting us do that. Well, our entity class takes in a definition, which we do. It's this animations. No, we fixed that, and it is crashing for some other reason. Entity is a nil value in the walk state, so I think, yeah, our entity defaults to the walk state, because if we take a look at our entity class, we're actually actually, it doesn't have a default state, but it needs one, because when we Let's take a look at our scene and see when we're changing our state. We change our state for all our other entities. Huh. I don't get why we're crashing then, because we're giving us an entity and then we're not doing anything with it. So it's something in the way. Oh, actually right here. We are trying to render it, so maybe if we don't do that, we'll be able to see our game again, and it is not working still because our entity walk state. So I guess I don't know why it's defaulting to a entity walk state when we don't. Let's take a look at our entity class again and see if there is a default state machine, but I don't see any. This is just the function to change it if we call it. We aren't updating our entity, so it shouldn't crash there. We do render it here based on the state machine. So I'm curious if we take this out, if we shouldn't see our geckos or our player, but I'm curious if we're able to run the game if we take that out. We're still not. Okay. But we're not updating, and we're not... Okay. You know what? Yeah, we're going to have to make a different function for this. Because we don't want to have to pass in any dummy animation values to our map object entities. We don't want to have to worry about that. So I think what we're going to do is we're going to go to our scene. We're going to take out all this stuff. We're going to take out all this stuff because we don't need our entity class has reference to all the states that every entity gets, but our map object collidables aren't going to have any states to change or to do anything like that. So I think we do have to decouple it and just make our own class of map object. Maybe we just call it map objects. That makes sense, but we'd have to do it separately. But let's take a look. We'll delete our old gecko instantiations because now we're putting them through a random direction here. And then let's take out our render for our tree object, which we aren't using correctly at the moment. And then we don't need to render our gecko because it's in our entities. So let's take a look. Our game should run here. Motherfucker. Oh no. What's going on? Entity walk state. Crashing. Ooh, that's the same, like, our tree wasn't causing that, apparently. Because we took out our tree and it's still crashing. Let's make sure we don't have any instances of our tree. We don't. Let's see if we have any instances of any other entities. We've just got our geckos. Got our gecko states. Okay, yeah. So why are we crashing? This isn't so pretty. We don't change our parameters that we initialize those states for, so why are we crashing? Let's resort to a git diff and see. That's all commented out, so that shouldn't have done anything. That's commented out, that shouldn't have done anything. I don't see why it's crashing, because we didn't change anything. Anything we changed, we accounted for. Because our change animation needs a string. Oh, wait. Entity walk state. We took out our self entity in our entity walk state. So that's probably it. We do crash on walk state, not idle state, right? Walk state, yeah. Okay, let's add that back in. We shouldn't have deleted that. I don't know how that happened. But we'll go back into our NeoVim here. We'll go into our walk state. And we'll make sure that our self.entity gets entity here. Now, that is what we pass in the init, and then we save it as a field so that we can change our animation for it. So now, let's see. Should run. Yes, okay, cool. So I'll leave us some notes, and then we'll get our git SSH key set up on this machine, and then we'll call it a night. So we'll go over, let's harpoon our notes, which needs to be here. Okay, so we're gonna say add in map object class with collision detection. Okay. Let's do this for next episode. Entity tracking. Yeah, you know, I don't think we're gonna be doing this anymore because our game is different now, but we did do this. Gecko directions, we did that today, which is good. We do need to add new bricks. Okay, that's okay for now. I will set up, I mean, I guess might as well set up my SSH key right now. So we can do a git commit here. I'll go add, we'll add a SSH key, so we'll do a new one. And we've actually got to do this different. You know what, I'll do this off stream. We won't worry about it tonight. I'll do it off stream so I can do a commit. But I am curious. We could raid my favorite programmer, John Blow. I raided him with 2 viewers yesterday, and he said, thanks for the massive raid. So, that's life goals right there. Thanks for watching, guys. Tomorrow we'll be doing map collision detection, so stay tuned if you want to see that. I'll see you guys later. Yeah, Nightman.